Okay, the next part is that we need to build this circuit, right? Now we have the state transition diagram and we are supposed to build a circuit essentially to determine what kind of circuit can actually achieve this state transition diagram, right? So for that we have been given with a set of ideas to how to determine or how to define this set of states, right? So now there are four states as we know, and we need proper representation of all these states in some way in our circuit. For that we know that we are supposed to use JK flip-flops now, and we need uh, now there are four states, right? So we need, if four states are there, we need some type of I mean each flip-flop can only represent two states, right? So there are some 2 to n number of flip-flops are necessary to build our circuit at least, right? So in this case 2 is actually 2 to the power 2 is 4, so we know that we need two flip-flops in order to build this circuit. So these two flip-flops we can assign in various ways, but to simplify our calculation or our circuit design, they have given us with the state definitions, right? For each state, there is a uh, there is a QA and QB, or A and B flip-flops are supposed to be like this, right? Essentially, uh, if the circuit is at state 0, our flip-flop A will be at 0 state and our flip-flop B will be at 0 state as well, right? Like that you can define how you want to do this. But anyway, after defining this, we can actually go and construct our entire excitation table for our two flip-flops, right? For that, let's construct this state transition diagram. We have I, right? And I will go for current states, right? It will be QA at this level T, right? Then we have QA at, sorry, QB, right? These are the current state or at time T, right? Then we have next state. What we are trying to get for each of these, right? Now there are uh, two flip-flops. Each one of these need to have a next state, right? QA T plus 1 and QB T plus 1. Okay, so then for each of these transitions, right? QA will be going from T to T plus 1, QB will be going from T to T plus 1. So for to achieve this transition, we need to determine uh, two uh, excitation signals for each of these flip-flops, right? So I will go as let's say JA KA, okay? Then I need JB KB, right? So these two will be for A flip-flop, right? These two will be for B flip-flop, okay? So now how to fill this? Let's complete the table first. So yeah, this is going to be standard inputs, because I mean there are exhaustive list of like there are three inputs now, right? Current state of I, current state of A, and current state of B. So these are exhaustive list. I need to complete everything, so I will just complete it, right? So 1 0 0 1 1 0 0 1 1 0 0 0 0 1 1 1 1. Now you know the logic from here, right? And actually you can now determine what is the current state and what is the input. Based on that you can go to next state, right? So that's the idea. Now we have made our state assignments such that 0 1 2 3 4 are uh, corresponding to the 0, 1, 2, 3, 4 of QA, QB, right? QB will be the least significant bit, QB will be the most significant bit, right? Because this one is going to be, let's take the color maybe. This is 0, 0, 0, 1, 1, 0, 1, 1, right? So this is the state transition we are trying to get, right? So because of this we will have that transition possible, right? If we are at 0, 0, we will be going from 0, 0 to 0, 1, right? 0, 0 to 0, 1. If you are at sorry, so this is for input 0, right? If input is 0, we will be all the time we will be staying at S naught, right? So S naught is 0, 0, so this one is supposed to be 0. If input is 0, no matter what is the current state, we will be staying at or going back to the S naught. So all these will be, if the input is 0, all these will be 0, okay? Because we are going back to S naught, okay? If the input is 1 and we are at 0, 0 state, then we are going from 0, 0 to 0, 1, right? This is the state 1. Then if the input is 1 and our state is 0, 1, we are going from 1 to 2, right? 2 is like this. Then if we are at 2, we are going to 3, right? If we are at 3, what is the next state? We are at state 3 and we get a input as 1 as well. In that case we are staying in the same state, right? So it is like this, okay? Now you can get this excitation table for JK flip-flop, right? Let me just redraw it here for quick reference, right? If I have a QT and I need QT plus 1, and my JK are supposed to be something like something, right? So what is the way? Now I'm just copying this one from previous one, right? 0, 1, 0, 1, 0, 0, 1, 1. So 0, 1, K does not matter. Here J does not matter. This one is 1, this one is 0, okay? So this is the excitation table of the JK flip-flop. Using this, now I can complete each of these transitions. So let me show how to do that. So now A is going from 0 to 0, right? If it is a 0 to 0, we are using this one, right? So J is going to be 0, K does not matter. So J is going to be 0, K does not matter. So how about A going from 0 to 0? It's the same, right? How about A going from 1 to 0, right? If it is 1 to 0, you can see here what is the transition. 1 to 0, J is going to be does not matter or don't care condition or X, right? So don't care 1, right? Don't care 1. Then how about 1 to 0? Again, don't care 1. Again 0 to 0, right? 0 to 0 is similar to here. So it's going to be 0x. 0 to 1, you can again refer from here. 0 to 1 is 1, don't care. 0 to 1, then 1 to 1. This also 1 to 1, right? If it is 1 to 1, what is the transition? Don't care 0. Don't care 0. Okay. So this one I referred for the A flip flop. What about the B flip flop now? You can do the same thing, right? Which is 0, 0. You can copy from the same way. 0x 1 to 0. 1 to 0. What is the transition from 1 to 0? It is going to be x1, correct? Then we are going from again 0 to 0. So it is also 0x. Here again 1 to 0. So x1. 0 to 1. 0 to 1 is 1x. right? 1 x. Okay, so then we have 1 to 0 again. 1 to 0 is x1, right? The same as this one. 0 to 1 again, so 1x. 1 to 1, 1 to 1 is x0. Okay, so now our circuit is kind of determined because we have set of excitation signals, right? Then if actually we come up with the boolean logic circuit for each one of these uh, columns now, right? Now we know our current three input states, right? We have our three input states or input signals, and based on these, in order to achieve this next stage, we need to set up this A and B's signals or excitation signals like this, right? So that's the entire idea. So if we have this signals determined, then we can actually set up this as our inputs to our JK flip-flops, right? There are two JK flip-flops, and these are the inputs for that, right? So we have a set of don't care conditions, and you can select each one of these columns and figure out a simplified circuit for that. Let's see how to do that. Okay,